Activity 12.2, Generalizing Transformations, is going to be a nice way for us to generalize what happens with the different types of transformations so we can predict where those points will end up like we did in the last activity. Again, you want to type in the bit.ly URL right there, and then I will head over there and open it up too. Okay, so the first one's reflections 1, and we have a triangle given. What we want to do is write the coordinates of A, B, and C down. So A is at -5, and 4, B is at -1, and 4, and C is at 0, 2. We write down the coordinates of the prime. So we have 4, -5, 4, -1 for B, 2, 0 for C. So we're going to show the line of reflection. This is equal to y equals x. We can show the movement of the points. This is where your points go on each side of the line of reflection. Now we're going to head back to our notes and see what that will look like. Okay, so these points A, B, C, A prime, B prime, C prime came from GeoGebra. We showed the line of reflection y equals k. So in the box, if the line of reflection is y equals x, the pre-image point xy is reflected to what? Well, if this is your x value and that is your y value, it looks to me that those are flipped. So now we get a y x. When we showed the movement under points, what do you notice about the dotted lines? They were not green, but the dotted lines are parallel. The dotted lines are perpendicular. That's our upside down T to the line of reflection. And the line of reflection cuts each dotted line in half. Those are things that we talked about earlier that we could see on in GeoGebra. Okay, so go ahead with that same activity, do reflections 2. We're going to try to generalize it for the y-axis, the x-axis, and then the line y equals -x, which is the y-axis and the line y equals -x is what we had when we did the reflections by hand. Then we're going to look at sequences of 2 reflections across parallel lines and perpendicular lines. And for these, I'd like you to look those up in your e-text on page 824. The next page is more combination when you have 2 reflections across parallel lines or perpendicular lines. And this one is in your e-text on page 825. Go ahead and read those to fill them out. We are then going to go back into GeoGebra and we are going to generalize our rotations. So I will meet you over in GeoGebra. Okay, for this one, there's a slider on the top for rotations. Right now it's set at 90 degrees. So you want to fill in the coordinates for points A, B, and C. And then on the grid, see where A prime, B prime, C prime ends up after you've done a 90-degree rotation. You'll then use the slider to go to 180, jot down those points. You will go to 270, get them down, and 360 maps it back onto itself. So for each of those angles, you want to write down the coordinates for A prime, B prime, C prime of that pink triangle. So for our rotations, I just filled out a 90-degree rotation. And if this is X, And this is why after 90-degree rotation, it looks like they're flipped. So yx, but it also looks like y has the opposite sign. So negative y, but the x value kept the same sign. You want to do that for 180 and you want to do that for 270. The next one is translations. So I'll meet you back into GeoGebra after you have finished your rotations. Okay, translations number 1. It says change the coordinates to A is 1, 3. So my A is here, and I want to go to 1, 3. B has to go to -2 and 4. And C has to go to 3 and 0. So this is just following the instructions above where we have to change the coordinates. So those are the coordinates that are on our piece of paper. And now we can go ahead and then this one actually shows you the coordinates of the A prime, B prime, C prime. So it looks like we have A prime is at Okay, I just noticed that the vector on this one is a bit different than I have in my notes where it says you go 3 right and 1 up. It looks like we go 3 up on this one. So let's adjust that into our notes. I'll meet you back at the notes. Okay, so once I change it to 3 right and 3 up, and this is vector notation, in those triangular brackets. And the first one is where you go right or left. If it's positive, goes right. If it's negative, goes left. The second one is up or down, and positive, up, negative, down. So we go up, right 3 and up 3. And what it looks like is that it just adds 3 to every x value and 3 to every y value. And you can do translations number 2, but if your vector is AB, it would be x plus A and y plus B. So this one is generalizable for everything. When we have reflections, we said we could only, or we would only look at the x-axis, the y-axis, y equals x, y equals negative x as lines of reflection. When we had rotations, we looked at 90, 180, and 270 degrees. When we do translations, we can look at any number. We can generalize this for any number. There's going to be one more, and that's our last one, which is our dilation. So again, I will meet you over into GeoGebra. For the dilation exploration, we have a rectangle this time, and we have a scale factor here, and we can see that we can make it. If it's 1, it's going to be the image itself. By the way, we can also make it between 0 and 1. Here's 1, here's 1.5, here's 2. In our activity, it's asking us to use k equals 2. We can show the coordinates. We can show the image coordinates. We can show even the height and the base and the raise. This is what I was measuring by hand. And I will meet you back over in on our notes. And for the last one, I copied over the coordinates of the image, the A prime, B prime, C prime, D prime. It looks like all of those were times 2, which is a scale factor. And that means if we generalize it, again, for any dilation, if the scale factor is k, we multiply that by the x value and the y value. So everything that we have written inside of a box in this activity is going to come in handy when we get to the next activity.